So what you guys are hearing now is Wolfram Tones. He's a gentleman who did Mathematica. Probably, Mitch, you want to walk me through this one?
Yeah, Stephen Wolfram is, some of you may know him. I'm sure he was the youngest guy ever to win the MacArthur Genius Prize. He did it some time ago. He also got his PhD from Stanford, I think at the age of 19. And he went into reclusion after making a program called Mathematica, which made him a multi-millionaire. It's still used today and everything. Actually, the Mathematica engine drives a lot of other products. He recently came out with something called the Wolfram Search Engine, which is basically the closest competitor to Google, not Bing, but the Wolfram Search Engine by far. It's much more integrated than we can. There's Mathematica. So it's actually, you can ask it a question and it gives you direct answers, and it's much more real. His basic discovery was autonomous theory, which was, simple rules have larger ramifications when they get repeated and relate to other simple rules. So that's it. It's not that deep, but actually, fractals, etc., come from these kinds of things. I'm not fascinated by fractals anymore. I think at some point I was, but I'm not. He is the king of fractalization, to the point where he's claimed that every kind of science, and he's written a book, took him 20 years to write that book called A New Kind of Science, where he says everything is about his series of patterns and pattern thinking, especially through basic rules and autonomous theory. So he's rewritten everything that is known in psychology, everything in literature, saying Shakespeare is kind of a hack. He's rewritten everything in music, which is what you were seeing with his ringtones thing. He's rewritten Google. He's rewritten architecture. And if you see, for instance, his architectural projects, which is more my sphere of influence, he'll say, there's no point making a building design anymore because my engine can create a building of any sort, anywhere, with any shape or any kind of position.
And then optimize it.
I could be Palladio, I could be Frank Lloyd Wright, I could be someone you never heard of before. I can reinvent entire styles, the new Gothic, whatever. And so he'll go and he'll write these simple rules, and then click, out comes one of his buildings, and you're shocked because it's so incredibly ugly and wrong and clunky and unsophisticated.
But that's the first. It's the first iteration.
It's the first step, but he's a massive synthesizer, global synthesizer. So I guess I've been talking to Paul, and I just wanted to show him what he's thinking about when you start looking at Wolfram's his music engines. And I think this is really great to see this because while we were talking over the break, here you can see on the top that's the code. So that's 55.27, and this is his influence. It would be under rock, R&B, blues, whatever country. But actually, that's just bullshit. Wolfram just says these are structural categories, and then if you scroll down a bit, it's the randomizers, right? The random styles that make entirely new categories that he says are the future of synthesizing and thinking about these kinds of loading. So you can change the instruments. You can literally change the music on the fly to anything. So he makes the argument there's no point in inventing a new piece of music because he's invented every piece of music that could ever possibly exist within an MP3 file of a certain size. And they're very clunky. You can hear it. There's nothing. Maybe this will be cool 50 years from now.
No, it sounds like a bad.
Yeah, it's endless. But it's visually generating this new pattern that becomes a new musical sensibility. So, we had another project.
That's cool. I'll remix that.
Yeah, so you're saying
I'm setting myself a ringtone of some weird mathematical algorithm. And this is what it looks like, by the way.
Just to go back to what we were saying at the very beginning, which is that humans as basically pattern recognizing things. I think that the pattern creation isn't so much the important thing as the ability to discern between a good pattern and a bad pattern. So, it may be true that Wolfram has invented everything that can possibly be invented, but his machine is unable to say this is a good invention and this is a bad invention.
Right, but exactly. But these things here, these categories, he says, are algorithms that find good patterns that represent classical music patterns. So, in other words, a completely random pattern is constantly generating it. He's written a script to find patterns that represent classical configurations. So you can get, the more details you add to that algorithm, whatever you define as good, the more you can kind of cut away all the fat and find a particular pattern that actually would be some elegant piece of music. In theory, although he never really takes to that depth, but got to hand it to him. He's tackling the entire field of music, and then
it's the field of knowledge as you know, and I think that he's got a good idea. It's just these are all first iterations, and you have to remember if there's some sort of recursive logic to how software works, it's about optimization, and so you choose and select things that you give a subjective sense of the good. If it's a good sound and you respond to that, then you'll make more songs in that same style that you feel as a good sound. And slowly but surely you'll build a vocabulary. If you go to Amazon, for example, and you buy a book, and then you buy another book, and you buy another book, it builds a profile of your taste, and it's called collaborative filtering, because it's building a statistical model of your taste. So what he's doing is a similar thing, but it's a little random in a way that he's taken all the ideas of what is a good sound and automated it. But I could actually see you being able to generate reasonably good music if you filter through and comb through and then fine-tune the algorithmic choices to what is quote-unquote good.
It's because it's pointing, not inventing. I mean,
it's mathematical generative engine.
There's, I guess, what's his name? Ray Kurzweil would make this argument. That's a jazz pattern. Interesting. It's a beautiful pattern.
It's okay. I can remix it.
So Ray Kurzweil, he's going to make this point about we touched upon artificial intelligence, but he's saying what's the difference between the algorithm or machine-generated systems and human-based comprehension of said systems. He talks about it all comes down to sentience. And sentience is this undescribable thing in science. We just don't ever discuss it. It's either a miracle or it's a kind of, it represents the soul. It represents what we say is, the kind of the goodness, right? How we can instantly kind of recognize something as being special. He brings up an example. He says, let's get this thing. He says Kasparov was playing Deep Blue in a game of chess. The world's grand chess master is playing a computer. And he goes, if you think about the computer, you have 60 seconds to make a move. In those 60 seconds, it does something like 50 trillion calculations per nanosecond. And in those calculations, it's actually playing a full game of chess, deciding what all possible moves are, and then deciding the moves a pawn or a rook or the queen, etc., and then making a decision. And then also embedded inside that algorithm is every game of chess Kasparov has ever played, recorded in Deep Blue. So it knows every response that he's ever made in a recorded chess game. And then it gives a percentage of what's the most logical move it can make to beat him, and the highest percentage that it'll do it. And so that's in 60 seconds of thought. And then it makes its move. And Kasparov has got 60 seconds to respond to that thought. Now, kind of think of the human brain, 20 pounds, whatever it is, and what type of calculations it can possibly do. You can measure it maybe in the speed of synapse connections, which is actually an interesting issue because it's electrochemical, so it's going to be a lot slower than photon-based systems. So a computer can think faster, period, because it's light, not chemical-based systems. And then, then he's making these moves, and he does something that is not calculable. It's called, the kind of the sentience, or the human will, or his kind of internal agenda to kind of trick himself to win against a machine that knows everything about him. Anyway, the end of the story is that he did lose, and he lost again when they had another rematch. He won a couple of games, though, which is actually a tour de force that you can beat a system like this. Although at the end of the day, is it artificial intelligence? And the scientists, the CogSci guys, said absolutely not. Deep Blue is not artificial intelligence. It's just sheer force of calculation over someone that clearly has intelligence. So and the thing is, it's not really learned. It's just an historical prepositioning program.
It's like Google Translate. It doesn't actually attempt to translate. It just uses its database.
It's just not logic structures.
That's why it works so well.
Yeah,
it worked, but it had it, and maybe chess isn't a true measure of intelligence. Anyway, so I was thinking about a lot of things that were being said today, and I'll give a brief kind of summary of what I'm hearing, but I kind of find it absolutely fascinating that Paul's using his app and he's mixing a series of incredibly beautiful, complex pieces of music simultaneously, scratching them, overlaying them, putting in more pieces, adding to it. Some level it looks really fucking simple, as if, this is second nature. And then, but if you stop and think about it, pause for one moment of time, all of the things that are happening in this kind of event and in the technology and the craft that's being produced is unbelievably, sophisticated. And we're at this point in society, no matter what discipline you're in, we are thinking at this pace, standing on the shoulders of giants, who are standing on the shoulders of giants through huge walls of knowledge, right? To build up these systems and kind of remix and find the kind of the what might be next or what's funky, and knowing that next is only incredibly temporary and a liquid kind of modernity. So I was thinking, well, how the hell can an architect ever possibly do it? As an example of another discipline group, I can't take an iPad yet in my mind and then scratch in doors and windows, volumes, staircases, public spaces, and private spaces, and then start making some funky city going on. I mean, I did do that.
SimCity.
In the 90s, SimCity, actually, how we think about cities, we were knowing that the remix is absolutely the kind of the thought, the mashability, whatever the terms are that weren't invented then. But we were certainly, listening to Run DMC and thinking the city is like this, but couldn't quite get there. Not sure that we actually can. So, as kind of being in charge of thinking about what discipline groups might be, there is a kind of a sensibility that the DJ in and of itself is a very strong craft position. It's actually a very strong discipline arc, because it is merging every kind of art-based system, media-based system you can imagine, and doing it with a kind of fluidity that is exceptional. And it's learned. You can actually pick this up and do it. I mean, we're in the same generation, but when I learned drums, I played drums. I learned the old school way, and that's how I did it. And as soon as I got my first Mac and started sequencing things in rhythms with the computational system, I realized there's no way my 2 feet and 2 hands are going to ever do this. But then responding to it, having it live while I'm playing, that became super cool. But I was the kind of deficient mechanism when it came to the rhythm system. So anyway, let's fast forward to today, what we've been doing in architecture. What we made is a kind of synthesis of a lot of these forms, a very fluid architecture that is hackable, scratchable, mashable space, where this was a skyscraper design that you could hack and the thing would move and respond to a circuit board that was set to a group of actuators into fluidic muscles on a skeletal frame. And you gotta scroll down. So this is it. We were delivering on site. Axel Killian was my colleague at MIT who did this, Philippe and Peter Schmidt. So this is, I think it was a 5-story skyscraper, all made of fiberglass components, pre-tensioned, and then these, you see on the sides, can't see shit.
Can't see, yeah.
Oh my God. Let me see if I can get another. Can you see that? That's moving. Okay, that's some of the MIT geeks. That's him with the board where you can scratch, basically move these sliders, and it moves the fluidic muscles, which change the joints. The skyscraper moves on the fly. It's kind of like a big phallic symbol, you go flaccid or really stiff or wiggle.
It is pretty
rotate, vibrate,
But why this is something where I'd love to ask a quick question. Is the idea of verticality and how people think of, if you think about what the elevator did in terms of revolutionizing buildings, right? The corridor, also one could argue, was a major invention as well, when people decided we could actually move through the space and have connectedness between different sets of other rooms. So there's a couple really interesting essays about the way the elevator revolutionized modern architecture. The browser has revolutionized the moving into spaces of information. So whenever I see this kind of material that you guys are talking about, I'm just wondering how many other shapes. That's where, the Wolfram model, if they ran that building through one of his algorithms to optimize it or to figure out some other like, you know, Greg Lynn's stuff. He's a blob. You guys know Greg Lynn? He's an architect. We had him doing some lectures here a little while ago. Oh yeah, that's true. His stuff is based on Deleuzian critique of kind of circularity, and he calls his stuff, blobjects. And they're kind of design structures that are based on playing. Wow, you guys, regretfully, you're seeing everything like slightly, like much darker than it is. That's a chair that's been authorized. He works algorithmically as well. I mean,
Yeah, absolutely. Actually, you brought up a really great point. Maybe Greg Lynn is kind of, you know, he's got this kind of the culture of the blob, that these spaces are universal. All this comes from Frederick Kiesler and the Endless House. There was this kind of a point where we realized we don't want to do any more English Tudors or Spanish colonials or anything Victorian. That architectural space, even modern space, didn't have to be square or blocky. It could be any kind of form. And he started working with these infinite modules, and they were slapped together. I know you can't really see it here, but these are all kind of bulbous forms called metaclay. And the metaclay kind of attracts or subtracts these kind of cavitation volumes that, like planets, they gravitate to one another. And they're extremely liquid. And they make kind of shapes. It's basically controlling particles or controlling blood or water, and then making it solid. And this is very real in computational modeling. So this is one example. However, it costs a fortune to do something like this, and an extremely elongated amount of machine time to produce these parts.
So what about stereolithographic printing?
Right. He uses that. That's exactly what he's doing. But it takes a long time. So what he's been doing now is something like comes from, I think, the DJ culture, where he's decided that it takes me too long to make these blobs and combine them, and he's done this. You say, let's say furniture. He's decided that he can take recycled toys, right? Any kind of recycled toy, like little that you find in China, like little cheap dolls or whale shapes, or here fish shapes. Same kind of complex geometries. And what he does is he pre-scans them and then builds these same kind of liquid forms, but not rebuilding everything, taking existing pieces and combining them into totally new things. And this is one version. Hopefully, I've seen 20 or 30 of them. But this is not unlike a piece of music from the 70s that's now been, or Billy Squier, that Run DMC then starts sampling and scratching and moving on top of it. Unfortunately, though, architects, do you guys see where the link is? Let's see. Oh, here. Architects takes a much longer time to kind of create this synthesis, but the thoughts are instantaneous and liquid and fluid. Here you go. Here's some more pieces. So he was in the Venice Biennale, and he won the Lion Prize for these works here. And they're all they're highly controlled. Maybe I can. Okay, it's just a slow internet connection. Can you guys see that? Yeah. So that's this. He'll take a weird ducky toy like this, and he'll scan it, and that gives him the kind of the control points. And they machine it with a 7-axis mill, and they interlace them together. This is another designer with kind of a similar idea. And these are the base toys that he buys, which normally, to make a blob like this in the computer, would just simply take too long. Why do it when it's already been invented? So he's finding pieces of the world that are out there already and combining them into his new logical system, what it might be, squishing it into a chair or whatever. So I think he's kind of you can see that, super kind of a creative guy. And, and then he'll make an argument that it's green design because it's recycled. That I don't exactly buy. This is actually radically beautiful.
Because he's not these aren't the original toys, these were scanned and then it's refabricated again, right?
Yeah, it's matched.
Yeah.
It's manual. It's not
recycling process.
It's not recycled, no. But it comes from also, I worked for Frank Gehry for many years. And Frank Gehry's larger secret is that he literally takes a piece of paper and he'll crumple it up, boom, and he gives it to 50 architects. I was the guy that would scan it, put it into a CATIA, which was this a very very big, complex program to make those surfaces realizable, and we move it to Rhino, and we optimize it, and then we'd print it out again, and you get this crumpled piece of paper, printed out, machine made, and it would be turned into a building. But the architecture, the kind of thought, actually stopped with his crumpling of the paper when he was satisfied that it was ugly enough, which is absurd. So there's no architecture after it leaves his little desk. When he leaves his desk and goes to me and 49 other people, it's all about computer processes that make this thing into the exact same thing it was already. And then we blow up the scale and produce buildings from Bilbao to the Experience Music Project in Seattle to the Status Center in at MIT, whatever the case is. But it's a very odd form of architecture. I don't think it could exist in this day and age because he doesn't care about light, air, views, orientation, environment, sight, circulation. He's really annoyed. He really thinks that he's just kind of a sculptor working with paper and cardboard, and that he has to stick plumbing in the thing and doors and windows. He'd rather not do that. So
the public has to suffer with the result.
Yeah, the public suffers with these kinds of with this positioning. But what's fascinating about this is that this process is becoming more and more accelerated. So we had been working on devices. Where's your Google thing? Called a luminous clay at MIT. So luminous. Spell it for me. Clay, which was kind of getting us to work much faster in the Gary process, right? So this is it. Yeah, it's an illuminated clay. So this is a board, our scratch board, for now when Frank rolls up this piece of paper, instead of going to 50 architects and on one of them and we make it into a building, it's actually he's crumpling. You can crumple your surfaces, any surface, clay, balls of wax, books. Beads, anything you want to put on this board, it's scanned three-dimensionally on the fly in real time as you're doing it, and made into a full-scale digital model that you can manipulate and make into a building. So now it becomes closer to this kind of scratching system where there isn't a year-long process of synthesizing this kind of this dumb little sculpture or maquette that gets mocked up and then becomes a full building. It's actually happening more and more on the fly. Because with these tangible interface devices, here's an example of it being used in conjunction with the landscape, are scanning and making these products in real time, fully doing it. At SVA, School of Visual Arts in New York, this was some time ago, wanted to hire me to kind of be their sculpture professor. I had been a sculpture professor before in Boston, but so that sculptors can start working with these things and start thinking and crafting in this particular direction. To the point where they actually were firing all of the guys, all of the professors who were responsible for clay modeling, figures, or busts, or portraits in clay, any kind of these things. Because they take up a lot of space, they use these skeletal wireframe models, and they put, you start molding and learning how to make faces and bodies in basic mediums like clay or plaster, etc. They said these people had their century. In fact, they had two of them, if not more. They're fired, and we're thinking that we can replace them with Mitch and some fancy computers like this. I was a bit shocked. I said, there's no way that you can do that. Manipulating things computationally is nowhere near the same as the physical one. In fact, it's actually the beauty happens when there's a feedback loop that's bidirectional between the two realms. So there's something very interesting about crafting in clay, scanning it, getting that scan, printing out the scan, returning it back to clay, and responding again. That's where this kind of synthesis is happening. But it's the speed and the acceleration of this kind of a system that becomes more interesting. So if you can imagine 3D printing, which today takes about, 60 hours to make something, we can do this in 20 hours, the size of this cup. Imagine if it happens in about a couple of seconds. So you can make the cup, then regenerate, crush it, regenerate it in another second, slightly modified. So, and then crush it, regenerate it again, slightly modified. And then you'd have not a cup, but you can change the cup and morph it into a donut. Same mathematical topology, but on the fly you would have a real world, not a movie, but a real world shape, physical shape being modified on the fly from A to Z, something like this. But kind of getting there, it's so incredibly slow. So I think it's this kind of the interface and the capability to think, which is thinking like a DJ. Is there a better term than thinking like a DJ? Is that what you want?
I use the term pattern recognition.
Just pattern recognition.
Yeah, because I mean, the good thing when I hear Mitchell talk about this is that I'm dealing with a lot of this stuff in the abstract, and I have to show up in radically different contexts as a practicing artist. The way you're showing up in an academy, I have to show up in cartoon, and the concert's in a briefcase, and you're sitting there talking to kids and the Minister of Culture under Sharia law and full U.S. sanctions. It's 51 degrees Celsius in the shade. And meanwhile, you try and figure out, all right, how are we going to do an event together? What does this mean? But the translation mechanisms of pulling from all this stuff, I love hearing the way Mitchell is. These are tools that, in a way, the real world, roll up your sleeves, pragmatic artist or architect or writer, you're going to have to encounter this kind of stuff, and you have to remember the tools are always changing. And I went to college in the ancient early '90s, and I remember when Telnet was new on campus, and that was like the buzz. It was like, oh my God, Telnet's around, wow. And a couple of years later, when the quote unquote internet, there was this guy who did Silicon Valley. You remember that guy? I forget his name. I'm blanking on it. But downtown New York, there's a couple guys that made millions of dollars off of like really lame applications that were like Prodigy. Do you remember the Prodigy? Yeah, it was super lame. This guy Josh Harris, he ended up doing this film called We Live in Public, where he videotaped himself, and they even put cameras in his toilet, so if you went to the bathroom of his place and he didn't tell you. Yeah, kind of weird geek chic kind of stuff. But what you're hearing here is somebody who's in the midst of a pretty much an amazing, I think, revolution of aesthetics, and the software tools that he's talking about versus what I'm trying to do is give you guys a little bit of aesthetic context. Because I really do firmly believe that science and art are mutually reflexive. The arts condition how scientists think about things. Some of my favorite physics guys, or theoreticians, they're striving to make science like an art in its own right again. But that's actually going back in time. We need to figure out some new forms to synthesize between these kinds of developments and getting people to think like artists and writers and cultural active people who, the creative impulse it's very difficult to quantify in these contexts. I would love it if somehow we could get the Gulf of Mexico and the artist's response to think about how would we come up with other ways of cleaning that art up, the oil up. There's people who are, hair is more absorbent, for example. Did you hear about this one where they were actually going to get people to donate hair because hair absorbs oil at a much higher rate than all this weird chemical dispersants and stuff. So they were going to get about 50,000 people to get haircuts and give the hair, which and that would have been pretty creative and really wild, like contemporary art event. I think that would have been.
I have a friend who just cut his really long hair, just cut it all in a sentence.
No, but you probably heard about it, right? They were going to do this happening where people gather in the Gulf, cut the hair, weave the hair into like these mats that could absorb the oil, and have an artist response because the hair is free and it doesn't cost billions and trillions of dollars, and people donate as a social interaction with the environment. I was like, that's hot. I thought that was one of the best high-tech and interesting solutions people could come up with right now. Because
We
nothing.
did it outside City Hall in Austin. They had free haircuts all day, and they were packing it up.
Yeah.
My daughter's school is collecting hair, so all the kids are going to the haircutting establishments, getting sweepings, and bringing it to school, and they just put it in this big sack, and they're going to ship it all down.
Yeah, and it actually does work. There's so many different strategies available right now. The interesting thing is, how do we get them to talk to one another? How do you find the bridges? Because the problem I'm trying to find with the arts in the creative scene is everybody is micro niche, and there's all these really intriguing projects and interesting stuff. But the connectivity between them all is probably, and that's where the mix comes in. I think where you can kind of have these kinds of. That's what probably EGS is like a little sort of catalyzer for that as well. Like you have all these different sparkling minds, showing up and exchanging. And the good thing about hopefully that you guys are realizing we all have our social armor down a little bit. We're just in the hangout mode, it's not. If there's any other questions or comments or you want to argue, feel free to jump But it's been a real pleasure going back and forth on this. We have about 15 minutes before lunch, so just a little. I wanted to jump from that to Antarctica because one of the things that I've been focusing on with current art projects is this idea of the acoustic environment. And Alejo, you were talking about the idea of frequencies. Antarctica is the only place on Earth with no government. And so what I did is I went down there and took a studio to all the main ice fields.
Other than Somalia.
Well, Somalia has a government. No, there is a government there.
Yeah, no, I'm just joking.
But it controls about 5 city blocks in the capital. Antarctica, there's probably less chance of you being kidnapped by Somalian pirates. So what I wanted to do is try and figure out. I'm sure you guys have heard of Kepler, the mathematician. He has a very famous essay called Six Sides of a Snowflake. And it's a very famous essay looking at this idea of natural geometry, of mathematics in nature. So if you ever think about what a snowflake or a piece of ice is composed of, it's essentially ice crystals are geometric form. And according to physics, ice forms at about 15 different times depending on the temperature it's made. So if you go to ice that's at 0 degrees, you could probably land an airplane on it, no problem. If you go to ice that's slowly melting at like maybe 21 to 32 degrees, you would not want to land a plane on that. You'd fall through it.
Just a weird sort of tangent on the fact that you're talking about the mathematics in nature. The original argument put forth by Descartes back in the day, I think therefore I am, and the existence of God, was actually based on a triangle. He said that since I can conceive of a triangle exists. It doesn't exist in a sort of tangible way that I can see it, and yet we take a triangle to exist because we can conceive of it. And the really strange thing is that any introductory philosophy student will tell you, well, that's totally bullshit. You can't say that God exists because a triangle exists. The two don't match. And yet, the mathematics, as they become more complex, are revealing what I believe in a lot of cases to be sort of almost like a holy geometry of the nature and how things function, sort of the patterns that you can see. And so, in a weird sort of way, Descartes was kind of right, that the mathematics are actually the God behind the existence of patterns.
There's if you go further back, Euclidean geometry, there's Heraclitus and his whole scene. The funny thing is, when you're looking at early Greek stuff, they were just riffing, like they get to the term Antarctica, for example, but the Greeks had never been to Antarctica. In fact, they barely knew what ice was. The reason they thought Antarctica was a place is that they call it the Antarctos. It simply means opposite of the bear. Arctos is bear, it means anti, So they already thought that the constellation of the bear was a symbol of some kind of mythic process, and it happened to be in the north. That was called the Arctic, Arctos. So the constellation of the bear, in this time period, if you're some Greek philosopher sitting in a dusty, hot-ass Athens a couple thousand years ago, how are you going to think about ice? They just thought it would be the place where the constellation of the bear would have this mythic presence. And that's to the north, and so that's the constellation. So Arctos, if there's a north, you have the Arctos, then you're going to go to south, Antarctos, which is incredible. But when you're talking about how people have visionary relationships to science and mathematics, say, for example, the square root of -1 was considered a holy number in Greece. And if there was a couple mathematical cults that if you revealed the mathematical holy number, you would be assassinated. They would kill you if I whispered to you, hey man, the square root of -1.
Fortunately, it was imaginary, so
and you weren't allowed to talk to Heraclitus, and he had this whole thing of the mysteries of the numbers, and if you went to go visit him, there would be all sorts of weird issues. Let me might as well just show cult of Heraclitus, but plus square root. Do you know about this one? The math cults?
When you're done, I got something.
I'm sorry, it's Pythagorean. Yeah, you know what? I completely... So erase the last 4 minutes if you remember. It was the cult of Pythagoras, and he would whisper mathematical secrets through a veil. And basically you just, these were, the square root of -1 was his idea of the mystical number at the heart of the universe. And so they had this whole thing of, just the universe, if you spoke the mystery of the square root of -1, it would unravel the universe and all sorts of bad things would happen. He was considered this kind of cult leader. But if imagine going to Athens under, in their golden age, and you have all these philosophers sitting on the soapbox and being like, yo, my philosophy, that's literally what they would do. He was the kind of like a high-end guy, and their whole idea was that you needed to be able to pull out of the norms of discourse and create a cult. So math, physics, again, these are all Greek terms. I mean, physukes, and so on. The reason I'm intrigued by both Heraclitus and Pythagoras, and again, I really apologize about crossing wires with Pythagoras versus Heraclitus, just one of those days. Anybody out there into this in the square root of -1?
I've been all over this for years.
Okay.
Well, more of these secret stuff. It has to do with an interest that I had in Western metaphysical occult traditions. But so I wouldn't. My knowledge of Pythagoras is that he took everybody to an island, actually, because he was actually in jeopardy, as I recall. And
I think he was eventually killed.
He was eventually assassinated. There's a lot of stuff having to do also with Pythagorean theorem, the square of hypotenuse, and all that kind
and
of
the
stuff.
triangle. No, that's what I mean. Because, but
it was a very productive idea. The other thing that every number also had its own meaning, which is very important, and also that numbers were not conceived as numbers; they were all alphabets. They were all letters. So each letter had its own numerical value as well as alphabetic value, which is something that they drew from the Hebrew and the Phoenician.
and also, if you go back to earlier Indian stuff as well.
Yeah.
The,
so as a consequence of this, all was transferred through into stuff like gematria, where you can take the first few books of the Bible and then assign numerical values to each of the words, and then you can come up with these kinds of conceptual relationships between words and entire sentences. And so that gives the movie Pi.
Yeah, sure.
It was a rip-off of that
Yeah,
idea.
Quantification of logic is all that, and that's just the biggest trend in American kind of philosophy.
Yeah.
It's the returning of all statements into mathematical values and then balancing both parts of the statement, and you get valid logical arguments just by using math.
Yeah. And it kind of turned into the whole cult thing had to do with assigning, meaning and the denotative values to symbols. And I find that personally ridiculous.
I kind of got a feedback or bounce off of this, because we were talking about some kind of preeminence of math as being, I don't want to put words in your mouth. There seems to be some kind of vast and deep influence on as kind of the undercarriage of most of the arts or philosophy or kind of anything you do. And I would say, maybe. I would think the opposite. There's a big problem. I was part of the computation group at MIT's birthing of the new discipline. And we actually had a serious problem with that. Because machines and the things that we want to learn through mathematical systems actually don't at all. And we can't even find a body of math, not even any field of math that comes close to these descriptions. If I was to make a very cogent example, imagine if Alan Turing was a poet, not a mathematician, and he invented the first calculating machines, first computers, right? So it's a poet inventing a calculator, not a mathematician. Well, what would that calculator be like, and would it be irrational or useless, right? And that's absolutely a kind of profound statement. So it led to this thing called shape grammar, which is this new theory that there's a kind of calculator that you're going to do, and I'm going to use you as an experiment right now. Just a couple of quick tests. But what is the shape?
Square.
It's a square. Does anyone not think it's a square?
Four angles.
Yeah, four angles.
Four angles. A square is fair enough.
I'm saying it's four discrete shapes.
Okay. Square is good. There's not a computer on earth that can tell you that unless you tell it to see it. Let me make another one. What's this shape? What's the shape? Diamond. What's the mathematical description of a diamond?
It's a square.
Rotating square.
Well, you can say, 45-degree angle or what, right? But you see diamond. Right? So you're making a visual cue and a cultural connection. Diamond, square, you're connecting. So, last part. Here's the entire universe. Any possibility. Okay? Now, I want you to come up here and, with this marker, make a rule. Any rule you can possibly think of.
A rule like thou shalt
I'm
not.
not telling you anymore, but I want everyone to watch his face. Watch him when he does it. Make a rule, and can you see him? Oh, stop. Okay. Okay, so there's his rule. Is he wrong? What type of calculation was he doing? Was it math?
Summation.
What?
A summation of points by drawing it.
I don't know. Was it math? Was it math of any form?
I'd say yeah. It's
No, you could mathematize it. But what was his choice in a universe of any? He could have written something. He could have put it. Okay, here. Is that wrong? That's my rule based on his rule. Is that, you know what this is? That's computation. That's a set of rules that lead to a set of principles that become the system. Picasso made up his own set of rules. Figures would have 5 noses and be slightly squarish with 2 eyes and 1 breast in the middle of their body. That was his set of kind of rules. No more wrong or right than any other set of rules. When Frank Stella makes these comments, he's like, sculptors don't think in units. But every time I sit down in front of one of these damn computers, I've got a filter, many layers of filter through software that tell me I have to think in specific measurements, that I have viewports to look at my space in 3D space, that I have certain tools to start drawing inside the computer. It's not what sculptors do. We don't even think like this. There's a whole different kind of calculus. It's not necessarily sculptors thinking of being mathematicians first on any possible level. In fact, when you were up there thinking to putting in that line, you were doing a design calculus. Could be an argument, art calculus, whatever that is. Actually, that's just as important, if not more important, and just as influential on mathematics as mathematics is to it. It's a dual prong kind of assault. I don't see one privileging the other at all. And in fact, we've been using the computational systems to this date, and we've reached iron limits. Machines cannot see a box. They can't recognize it as a box. We tried writing a code called, what was the name of this code? Something called, not simplicity, common sense was the code. Because we want to teach a basic machine that there are certain things that everyone knows. It's called common sense. And we tried telling it what a box was. They didn't know what a box was. Because to us, a box is something you can be trapped in. A box is something you can sit on. A box is something you store things in. A box could be a house. But there's an infinite realm of possibilities in how we think as sentient creatures. It's very hard to describe even in common sense, especially when we mathematize. Not that it can't be mathematized, but there's a number of array of logics going on there. And I like to think that the arts is just as powerful, if not more powerful, than the mathematical and the science-based systems.
To develop on what you're talking about, I would also bring in Ramachandran. And his ideas having to do with, like, when he was researching missing limb, false limb syndrome, his perspective is that the mind really just doesn't exist. It's an optical illusion, kind of, created by the brain. So this way, these non-verbal, extremely intelligent, non-verbal, non-conscious machines, these ghosts inside your head, can get you as an object, as a being, through the day. So like I'm talking to you, I'm walking down the street, here's a pole, I evade the pole. I'm still talking to you, I evaded the pole, I didn't even think about it, I didn't see the pole. You know, because I'm talking to you. How did I do that? Well, because there's this unconscious, very extremely intelligent mind inside my mind saying, oh, here comes the pole, don't hit your head, you idiot, get out of the way. And so you go around it. So this is, and I think this is really important too, because what we're talking about actually is kind of a refutation of the notion of consciousness, and that the whole idea of artificial intelligence is a false premise because there's nothing to be intelligent about. Okay, it's like this box thing. We just know what a box is. We've evolved over 4 billion years to understand shapes. You know, it's a very it's an organic thing. It doesn't have to.
But people,
and also furthermore, our explanation, what we're having here right now, is that part of our brain which is very linguistic, trying to explain and understand the part that it can't possibly understand or explain because it's one of these underlying non-conscious zombies.
Let's put it this way: the West is how you like some people call the Pygmalion complex, where you imbue objects with other qualities. Right? Most cultures have statues or gods that are like carved out of wood or stone and stuff like that. We always assign qualities to external objects. It seems to be one of the few human characteristics that's almost across the board. But at the same time, when you think about consciousness in its own right, that's something where I think the West is really, kind of trying to figure it out. And the funny part about what you were just saying versus what Mitchell's saying versus this idea of math is that human beings have an intuitive mathematical sense. If you go to a line and you're at a grocery store, and you see the shorter line that has 2 people or the longer line that has 5 people, you're going to judge that very quickly and you go to the line that has 2 people. You've just done a mathematical analysis of a social space. Intuitive, within 0.0 milliseconds of just the thought. We're always doing that at every level and editing the perception around us. But consciousness is what gives, I think at least, the structure. So when I was talking about the Cartesian issues earlier, and then talking about this idea of math, what I'm hoping we can think about is not only every word we say, every musical tone you hear is comprised of layers, it's comprised of small tone forms, sawtooth waveforms, you can call it all sorts of things. But what needs to happen is that I think math is probably more of the universal glue holding it all together. That's just my take on it. Do you know the composer Yannis Xenakis?
Oh, very well.
Okay.
He teaches stuff.
Yeah, okay. We worked together before he passed away. We did the first New York Symphony of a piece called Croner, where he did a series of analysis of turbulence of water moving through channels. And the idea was to look at turbulence and assign mathematical, analysis to it, and then make that become music. So it's this kind of, it's meant to evoke water. Now, at the same time, imagine if we had artists go down to the oil spill. We were talking about making that into music.
Yeah.
Like the viscosity of oil versus the kind of gradient of how water has literally a different molecular structure. How would an artist or a musician or composer represent that? Assign mathematical value to the density of the oil, maybe assign tone structures to the viscosity of the water. These are things that I think, if there was one thing I wanted to ask everybody here over the next day, as we kind of get deeper into this, is maybe to come up with some hypothetical projects where we all could see this kind of exchange process. We have photographers, we have choreographers, we have all sorts of people in the room, architects. What would you guys think is the common denominator for all of what you guys are looking at right now? Is there a common denominator, or is it everyone's specific interest is totally different and we're all just sitting here in our own subjective bubbles? I mean, it's something I just want to throw out there.
Yeah. I was just thinking if let's say Paul went with a team of folks to go down to the oil spill and get to the spill cam and actually take some serious measurements, sound-based measurements, and then kind of bring this up and extrude it and do some kind of a mix or performance based on it, which would be multifaceted. It wouldn't be just a sound condition. And then let's say you did a really quick one and you got a grant from the National Science Foundation. And then you played it and it was on CNN and a team of engineers saw that. And they said, holy shit, we didn't even, and you weren't trying to solve the problem, you were just there making a kind of, let's just say, that you were taking a position or an opposition, whatever it is. But then through that kind of knowledge base actually led to the scientific solution to solve this fucking problem. You know, right now, we do things like a chainsaw to cut butter. We take the world's greatest scientists and greatest minds with all the corporate money you can imagine and try and solve a problem that won't necessarily be possible to solve in that realm just yet. Because it's very hard for those people to reinvent or imagine a new kind of science or field to stop a spill at this scale. And this is already in evidence. 6 weeks of America's finest and people from all over the world are not doing it. I'd say let some art force get inside there and take a kind of new position. Maybe that filter could not do any worse. It would certainly upscale.
Have you guys heard of holographic theory?
Well, there's different kinds of hologram. I mean, there's the holographic theory of the universe, that the universe is made of multiple reflections that are all each complete versions of itself. That's what. What's that?
This is very similar to Spinoza's monad.
Yeah, or Leibniz's idea of the monad, or Spinoza.
Just because there's sort of, I don't know, just in the realm of the sort of the consciousness and the creativity and the sort of application of math into reality, I do believe that at some point, if you are going to take a holographic standpoint, that past the event horizon of a black hole, there is the unknowable. It is actually, information cannot escape. The fastest thing that we can understand, which would be photons, are actually unable to escape from the event horizon. And so, to me, it's almost like this sounds weird and strange, but the creativity and sort of unknowable and the unknown is actually contained within black holes, and therefore exists, but is not accessible in the sense of a direct, you can take it, because it can't come out.
Let's put it this way. I really think anything that we can imagine, if you can imagine the unknowable, it can become knowable. I mean, that's what's so weird about the human mind and the fact that, eerily enough, we alter the universe by observing it.
And and to me, the aspect of the human mind which allows that to happen is entanglement, right? Which is the only thing that can break the sort of the pull of the black hole, because it is instantaneous. It doesn't follow the rules.
No, black holes leak.
Yeah, they do leak
They
radiation.
leak radiation, and then it becomes catastrophic, and they explode. This is Hawking radiation.
Yeah, exactly, Hawking radiation. But the good thing, I like hearing between the two of what you guys are talking about here, is the idea of the unknowable. How do we even give that blank space on our, cognitive map? It's something, but that's art. How do we transcribe and translate these things at the edge of perception, at the edge of the creative act? And for me, again, to go back to a pragmatics, because the black hole thing is very interesting. There's a guy who I had for my book Sound and Bound. He's a physicist we did a series of investigating the universe through waveforms, and let me just show you this really quick here. It's called the acoustic wave spectrum, and it's a poster that's in a limited edition version of my book, where we took you through macrostructure to microstructure. A waveform, for example. Let me zoom in just so you can kind of get an idea. A waveform that would occur over several million years, for example, would be a waveform of global cycles, oceanic cycles, geologic cycles. But that's a waveform that human beings can't actually process. We are living it. Probably right now there's waveforms going through our bodies that we can't necessarily, like you're saying, it's unknowable, but we just all gested tools, and next thing you know, it's actually quantifiable and mathematical and so on. So interplanetary cycles take place over millions of years. There's a rhythm, there's a pattern, there's a tone to that. We keep going across the spectrum. Galactic cycles, literally the dance of huge. I'm talking, hundreds of light years long. Spatial structures that easily can be put in patterns. If we go down the acoustic wave spectrum to cycles and frequencies per minutes, per seconds, to the human, we actually only have a very small portal into the universe, which is through about 100,000 cycles per second. So that's a tiny little sliver of the actual phenomena going on around us. So if you even go below human hearing to the microacoustic realm, microthermal waves that occur in area, either gas, liquids, solids, organic substances, magnetic-acoustic waveforms. So this is a fun little poster, and I'm going to put this on a PDF for everybody in a little bit. So when you're thinking about acoustic waves, the human ear only exists within this little weird little sliver up here. But you think about how many other waveforms can occur literally from that scale and going further and further out. Again, is that unknowable, or is it we're using the wrong tools to measure it? You know? But well, it's lunchtime, I think. Is
That's a good point.
so when we reconvene, I'm going to have a memory stick of the posters, a couple other essays and bits and pieces. Did everybody get the essays and the reading material?
Yeah.
And there was your homework.
I don't believe in homework. It's like
It's the assignments on the assignment.
it should just be a good Socratic dialogue where everybody brings some information to the mix, and we just kind of get a better mix if you have better information. So later today, we're going to get into this idea of liquid modernity and its relationship to sound. Zygmunt Bauman is this really interesting sociologist who coined the term liquid modernity, and we'll have responses. Any last comments, questions? If we want to fight, so bring it. Otherwise, we meet at 4:00, and he's doing his lecture tonight at 8:30.